Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
There is the sample data store, right? We know how to connect our data now. Let's do that. Or let me do it from scratch itself. That we know what are we doing. What we will do is we will be blending while we were doing joins. What we did is we connected to data over here. We connected an Excel and we brought this table over here. We got the data source and then we tracked them for the join to happen. But then now we will not do that. What we will do is we will do a blend. Let's go over here. Let's see how is data getting blended. This is the orders data set. Among the samples who post our data set, this is the orders tab in which we have these. These dimensions and measurements. Now let me go back to this. And now we have seen how we view data, right? Let me view the data for people. And let's see that if I want to have a mix between orders and people, do we have enough data that will help me? I can see that in people, I have region and regional manager being two dimensions presented there. Let's see if we have something similar to that. I can see that we have that. We have a region being one of the common columns between the two, right? Let's see how we can blend these two data sources and like these are different tables altogether. Let's see how we can blend these two. That's my orders. And now if I go back to the data source and if I go over here and if I do a new data source, Excel, same sample data store, and now I'll drag in people. Now you see that we have the people data set which is over here. Now let's go back to the sheet. Now when I come to the sheet, what I see is both the tables have been added in here. Right. Both the tables are added. When I go to this, I see this. When I go to this, I see this. And we have seen that. We have a common column of region just presented there. We know that we can have some kind of a relation and this relation is being decided by Tableau. Data blend is not that flexible like joins because joins have left, right? And they have the unique things coming in and all those factors coming up. But blend is basically happening only based on one column being being common between the two. There is no such. That's why blending is something which is not a very, refined form of harmonization. It is a very crude form of harmonization. You have to be dead sure that you know both the columns have all the things in order to get your data together. But blending is not much recommended between people who work with data because it is it is heavily prone to errors. And it will throw up errors. And you have to do a robust data quality QA and all those things in order to. No worries. Let's not go into that, or rather let me go into that and tell you these things because try to avoid data blending whenever possible. But then this is a feature of Tableau and we need to be aware of it. Definitely yes. Now based on a common column, we are doing this. This is a feature that and Tableau recognizes these things automatically. Let's see a very short example about this. That orders. Let me pull in, say what should be up. Let me pull in order, ID on me. Let's put in date. We have the date right. Order date. Let me pull order date to columns. And let me pull sales to rows. Again, I see this happening now. Region is coming from people, right? Let me pull region into colors. You see what happens? Happens over areas. Data gets blended and we have the region's voice here says whereby the year and sales is coming from this table and excuse me and colors. The definition of these of the other bifurcation of the data is happening from the region table that is coming from the people's table. Now, if you can see, you will see that one data source is in blue and the other data source, as soon as I use from it, is in orange. See over here. What does that mean? That means that the orders data set is the primary data set which was being worked on. And people data set is the secondary data set which is being used to manipulate whatever we are doing from the primary data set. Always the primary data set operations will come in blue and the secondary operations takes will come in orange. Secondly, this orange also signifies that there is a blend that is happening and there is a data blending that has happened. One more thing that tells that this is the column which is helping. The blending is the symbol over here. It is telling me stop using region as linking field. Region is the linking field between the two data sources. Right. If I click on this click button, what it is telling is based on it. It is connecting. If you click on that, it will stop linking the two sheets based on this column and it will stop. That's data blending. Data blending is basically not much common. I'm not sure how many of you, if you've worked on Tableau before or if you have seen something. If you have seen people working on data, in the robust data engineering field, data blending is a very crude form of joining stuffs together. But then no harm in learning. Let's do that. You know what we can? We have now seen that how we do the data blending. Any questions, guys? No, we don't know. I'll consider to be no. Then let me know. Now, the next topic that we will discuss is calculations. And you will see that there are always calculated calculations or something that we are. We are always concerned about and how we do the calculations and why do we do the calculations and how does calculations affect things. Let's look at calculations, how we do calculations, and what are the various types of calculations. I'll not teach you calculations like every single formula or anything because that is very self-explanatory and you guys are smart enough to go ahead. If I show you where the formulas are, you can very well go and edit them and you can do. But let me show you a story whereby you know the different types of calculations come into play. Calculations come in various forms, namely, arithmetic calculator calculations, string calculations, basically arithmetic calculations. String calculations are the common ones which are used. Then comes the logical calculations, whereby we use the logical functions and statements. And then what we will do is we will see two more types of calculations that Tableau offers us, namely, table calculations and quick table calculations. These are some of the calculations that we will have a look at and we will see how we can work towards that. Before that, let me bring in again this thing, the orders data. Let me go to the sheet. If I want to overhead, first thing is let me do something. Let me first show you how to take counts and distincts. Count and distinct count is basically, again, it's very self-explanatory, whereby if you have a dimension and if you use a count function, what it does, it gives you, how many elements of that dimension is present in there. And then count distinct basically gives you the unique number of things that are presented there. Let's see how count and count distinct works, or how they work related to the related to every dimension that is presented. Let me do something. Let's say take state into the rows. Let me have sales in the columns. Now I have the states and their respective sales. Now, let's say tomorrow someone comes up and does that. The sales of these states are here. But I also want to know the, count of distinct items in there. What will you do? That is your sales figure. Now, the distinct items, when they want to see any time, like this is the count of items that we have. What do you do in that case? You use up. Definitely an item means product names. Products, basically product names, like how much of product is present in all these areas or all these states. When you want to do that, one way is to put functions and stuff, but then Tableau provides you with one more feature. What you can do is you can go to this product name, right click. Now this click, I cannot show you the click, but I'm clicking right. I'm doing a right click and I'm dragging it into the columns. Once I do that, see, Normally, if I drag a product name over here with left click, it will be as good as a dimension, right? It is coming in the dimension. But if I do a right click and pull it to columns, what happens? There are few aggregational functions that come up, namely minimum, maximum, count, count distinct and attribute. What do we need? We need count distinct in this case. Let me show you what is the difference between count and count distinct. Let us have count. And then let me pull this guy once more over here and our count distinct. You see what happens. Is 6 is 11. That does mean that among 26, 11 is unique and rest are duplicates. That's pretty self-explanatory, and this is something that I just wanted to make sure that you understand. And always you will find the distinct count to be less than or equal to the count. Never will it be more. Of course it won't be more. It can be less than or equal to this thing because this also has duplicates. In this case, now we have the distinct count of product name. I don't need count. I'll just remove count over here. We have this. What happens is aggregation functions. Once you have something, you just right click and you can take it up there, and you don't need to write a function or you don't need to do these things. Similarly, aggregation functions are available when we right click on a measure as well. But that is some, multiply itself, etc. Next is this. You know your stakeholder. He wants to see sales per item sold. What is sales per item sold? He wants to see that, can you show me what is the sales per item sold? Now this field is not presented here. What you need to do is you need to calculate a field. To have to get your calculated field options, there are two types of ways to get your calculated fields. One is above this entire data window. You will see view data and then you will see a drop down. You can go and click in your drop down and you will see there is an option called create calculated field. The other way to do is, you go to say anything, any dimension of the element. Do a right click. You will see a create. And from there as well, you can do a create calculated field. There are two ways in which you can create that. Get to the field, create calculated field, and you can use them. Now the only difference between the option is that in case you are doing a create calculated field on your product ID or product name or region or whatever, Tableau knows that this person is specifically wanting to create a calculated field on region. He also understands that this person wants to create a calculated field on the region, and the region is one of the dimensions that he is going to use in his calculation. That's why if you pull in calculation, like if you do a right click and do this, you will find that the dimension on which you had right clicked and created a calculated field that automatically appears in. On the other hand, if you see this over here, Nothing comes up because this drop down while a field doesn't know that. Which dimension do you want to refer to? One more feature is this arrow. You will find this arrow, which is basically a small guide towards all the functions that are available in Tableau. And not only that, it also gives you a text beside. See, there's a text beside performs a logical conjunction or two expressions. It gives you a very discrete, very small one-liner and also examples. One-liner stuff for you that you know what this means. This. Now, if you know that, you will understand and you can refer them. That's basically it. Now for us, what do we need to calculate? We need to calculate sales per item. For that, what are the fields that we need? We definitely need sales, and items are products or product names. What do I need as a calculation? I need sum of sales divided by items sold, the number of items sold. That doesn't mean count of product name, right? Product is my items and count of product will give me the number of items. Let me write a formula. You can go over here. And you can write this as well, like, from here you will get the form. If you use sum, what will happen? Sum and the brackets will come. What do I need to put over here? The sum of sales divided count, right? I can go over here and if I know, I can do this else. There is this referencing place, right? If I do count, it will give me all the count related functions. What I need is distinct count of product name. I have distinct count of product name. And the calculation seems to be valid. Let me up. I have created. We went to the calculation one day. I have created this. I've created this thing called. Let me rename it as forget. This is sales for items sold. Now sales per item sold comes over here. Any doubts that come to your mind till now? No, right? I guess not. Now, let's do something now that we have this coming up. Now that we have this over here, what do we do? We now will replace the count of product name from here. I made it more sales as well. And let me put sales was sold over here. Now, you see now, once I've done it, it gives me what is the sales per item. Sold numbers. When you do that, what happens is, you will see that an aggregated thing comes beside this. You see this. Calculated fields come with an aggregate and their aggregations cannot be changed. Unless the native metrics, where we native metrics are something that we change up. Whenever you create a calculated field using measures, there will be this AGG aggregation. This aggregation will happen and you will see this aggregation happening in the text. And this will come up when we have the two measures in a calculated manner. And that's how you write a formula. You create a calculated field and you use it. That's basically my first arithmetic calculation that I did. Now let's look at string calculations. In string calculations, what do we want? We want, customer names, say beginning with S. Now we have a range of customers over here. Now we have the customer names. Now from arithmetic calculations, we are moving to string calculations. We want to see the customer names beginning with S. Now suppose you are a company who have a range of customer names and you are targeting the ones with an S. To give them some kind of an offer. Now it will be difficult. If you want to filter, use a filter and then do because say customer name filters. Now you sit and do manually everything and you go kajak. You want to use it and you want to do it as a calculated field whereby you want to do all these things. This is going to be like overly difficult for you, right? Rather than that, what do? Rather than that, what you can do is one more. One thing is there which you can do is that can come to mind. One thing that you can do is you can put it in filter and you can use a wildcard and you can use starts with S. And then I guess you will do that. You can do that. And with the condition even. But over here as we are doing a calculated field and a more sustainable form of thing. What we will do is we note that we will be modifying customer name. What we will do is we will create a calculated field on customer name. Right click on customer name, create calculated field. Now we see that customer name automatically comes up. What is our criteria? That names that starts with S. Now let's see, what do we have as a formula? We do see that we have a formula called starts with, correct. Let me use this formula starts with. Let me copy this and paste it over here. As to my name. Now, what is the substring that I need to see? It is telling me it starts with customer name and starts with whatever name it will fetch from that. And then is asking for a substring. The substring is how it will what will it fetch from this column that you are telling. You need to define. The starting letter say yes. Then you apply and hood. I didn't name this. This one. Now that you have the calculation ready with you, now you know that. If I do this now what will happen after doing this kind of a calculation? Nothing but a Boolean value will come once you put this into the filters. If you put it in the filters, what will happen is a Boolean value pop-up comes up as an aggregation. Because we have told them that if it is S, then let us know. Once that S, this guy has referred to it as true. And ones that are known as it has referred to it as false. If how? Put calculation 1 in filters and then select true and apply what I see. All the ones with the letter S. That's how you know. You basically put this calculation over here and once you use the true thing, what happens is all the names with S comes up. Boot. You know that's how you do a string calculation. Now let's do a date calculation, maybe. Or let's do a logical calculation, then we'll look at a data calculation. Now suppose your manager comes to you and says that, you know what, can you please do a graph or a visual and tell me or highlight all the subcategories that are having a sale more than 1 lakh? What will you do? You will have subcategory and you will have sales. And what is? He told you that if sales is more than 1 lakh, then it is high. Do highlight it over here. As now you know that this is your subcategories and that's your sales figures. Now you need to highlight it. What will you do again? You will go and write a calculate. Go to this right click calculated field and overhead. What will you do is you will write the suppose it name it as sales target and the formula. We will use as we are using logical functions. What we will do, let me just remove this. Let me go over here. Do I have if we do have a if right? What is my first function? That is the sum of. Always remember, whenever you are using a measure in your formula, you have to use an aggregation. If you don't use an aggregation before it, you will get errors. If sum of sales is greater than 1, then what do? Is you have to highlight it. How would you highlight? You will say suppose, write it as high. And always the logical. Whenever you are writing a logical, if else always ends with an. Once you do that, you will see that the calculation is valid. Now you can apply. And you see something called sales target has come up in your fields overhead. Now what do? You pull the sales target into your colors. And you can see that we have a high and low populated overhead, whereby everything that is more than 1 lakh. See, all these bars are more than 1 lakh. Our highlight, like the ones which are highlighted there in blue and the ones which are below 1 lakh. Those things have come in green. And then you can, if you want to use your labels, you can go ahead and you can show your labels from here. And this is your label appearance. Like if you want to use it, you can show. That's how a logical condition works, whereby you are showing that you know what is it that is affecting. You know these things, and what is it that is affecting you, know the low and highs, and you can venture out with. There are many formulas in there, and whenever you get a requirement, whenever you get a chance, you don't do, look into it, and you can see what all formulas are there, and you can explore it on the visuals. That's about logical conditions. Next comes the two important things which are called grand totals and subtotals, which are called quick table calculations and table calculations. Whatever doesn't come in your calculated field, like whatever doesn't come in quick table calculations, come in your calculations. Now, what are quick table calculations? Quick table calculations are calculated fields where we apply calculation at a data set level, not at a dimension level or anything, but we have it as default calculations that are applied at a data set level. It applies to the entire table and it depends on the table structure as well. These are inbuilt functions where you don't need to write any formulas and you can, slice the things and compute, and you can compute entire range of the specified table structure. Let's see how quick table calculations can be used. The other day I tried showing quick table calculations, but then I realized that no, let's take it up with the other calculations. Now, this time again, let me have set date that people ordered, order date to my columns, and then let me pull my sales to my rows. Now I have this value. Let's do something. Now let me, pull another sales thing over here. Now quick table calculations come up with many things. Now let's see how it works. Now this one, this is that I brought I. Why did I bring it? Because I want to do some form of calculation. Just go over there, put a right click, and you will see an option called Quick Table Calculations. Now, if you see your goal, like whatever your metric goal is, whatever your calculation goal is, you can go over here and do it. Let's see how it works. First is running total. Running total is nothing but cumulative total. And let's see what happens if it. What happens in cumulative? Cumulative basically is, your first bar, whatever the value is, whenever you're doing a cumulative or a running total, gets added to the second, and that value gets added up to the third, and then that value gets added up to your fourth. You will always find whenever you are doing a running total that the first value will only match, because from after that it is aggregating the values and it is doing a plus till the end of it to show you what is the running total in between these years. But sales will be like, this is basically 2019 sales, 20 sales, 21 sales, T2 sales, and addition of everything happens whenever you're doing a cumulative calculation, and you will see that this is some kind of figure that will come out. That is like running total of sales along the table, and you get this value. Any doubt? Put it over here. Now let's look at that. The next thing, let me pull the sales again. Let me do what I click. And now what I do is quickly do calculations difference. Let me see it as a table. Let me put it. Now, what is this difference? Now difference in sales from previous year along year of order date. If you want to understand what is happening, it's basically calculating the difference between sales along the years. 2019 will always be a blank because we don't have a 2018 data. What do we have? We have 2020 data. And what is happening? This is getting subtracted from this and the value comes up. Same way, man. These are coming up. That is difference along the line. Next, let me drag in sales again. Let me go to quickly do calculations and let me do a percentage difference. Let me put this. And what do we find? We find percentage difference in sales from previous year along the year of date. What is the difference in sales between all these years? Again, let me pull it. Go to table and let's say I want to do rank. Or let me do a percent of total. Now percentage of total. What percentage does 2019 values of sales comprise among the entire pool of data that we have? Likewise, what you can do is, I'm not taking you through everything. Likewise, what you can do is you can go and explore the table calculations. And if it is something that you know where you get things that this is already presented here, let me do it. You don't need to write a function. Let's do like you know separately. You don't need to write a function and you can use this. Wherever you don't find in quick table calculations, you can variable, go to the calculated field and you can write the functions over there. The next thing that we'll talk of is table calculations. It is pretty similar to quick table calculations. That's called a table calculation, whereby we pull our year to columns, sales to rows. Now on sales, let me do a right click. And what we saw, quick table calculations. Now let's add a table calculation at table calculation. And what do we find in here? We find that a drop-down kind of coming up functions. A drop-down type coming up which is named as calculation type and then comes compute using a table across sales cell or specific dimensions. And it is always relative to previous, next, first, last, etc. First, let us select over here. If you want to use a table calculation, what do you do? Always remember, right-click on the measure and then you do this, do this table calculation. Let's do a running total. When we select running total, what happens is, running total. Let's select an average over here. And what happens when we do that? When we have this, let's do an average over here. Now you have one more option which tells you run along or or however you want to run across. When we tell run along or across, and we can do the calculation downwards or sideways. Over here we have the data sideways. We will do a table across over here. How I want my calculation. Here we have it. Now what we will do is, Now we see that that's a running average of the running total average of the entire data that we see. This is basically how you do the table calculations. In table calculations as well, you have, various different types of things which you can also use. Say, suppose you have sales over here. If you use a difference from, you will see that 20 to 22. You have this difference and then you have this. Then you have this. Likewise, you can explore the table calculations as well. And you can check what is happening and what is not happening. That's about this. Now let's look at a scenario for a company. An increase in its market share frequently translates into a higher profit margin. To ensure her company's sustainability, Jennifer, the sales manager, needs to identify growth opportunities for business and how to make the most of them. And she needs to determine and study the sales variance for year-over-year growth based on a quarterly breakdown. Simple, not sales variance we need to have on a quarterly breakdown. Let's do it. What does Jennifer want for herself? She wants to determine the sales variance year-over-year growth based on the quarterly breakdown. What will we do? What is the first thing that will we do? We need to see a trend in sales first. That typically tells us that we need a line graph to see, because line graph is, predominantly used to see a trend. It is also called a trend line graph. Right. We will see people calling it as trend line graphs. Line graph is basically used to see trends. Anyone who can guess? What do we use to show share of something? Which graph will be used to show share of something? What will you do? We have to do a time-based analysis. What are my requirements? Let me go over here. Jennifer wants to see like in a year-on-year. It's a time-based analysis that we need to do. We need to drill down at quarterly level. And because we want to know the difference or variance for Y or Y, we need to use a difference. Correct. As we need to here, what we will do is we will first take a year and put it in the columns and then sales to those. I have this line chart coming up. Now I need to go at a quarterly level. Who will tell me how do I go to quarterly level? We have discussed this. That's fine. But then you can take help of drill down as well. We have seen drill down this plus. If I do, I get the quarters right. What happened? Jennifer wanted what she wanted. She wanted to have the data at a quarterly level. We are good with quarterly level. Now what is the next thing that we need to do? We need to do a percentage difference. What we do, we will take another sales. Put it over here. Right click. And we'll go to quick table calculations. And from there, what will we do? We will do a percent difference. Now, when we do that, these graphs look like what you call them, like all the crooked sticks together, stuck in a particular view, and it looks very messy. Right. What will we do? What is another level of representation that we can do? We will take this sales thing, the sales peel, and let me put it to colors. Now when I put it to colors, This now makes a bit of sense as to us. Because what we have done percentage of difference, and now that it was looking as messy, what did we do? We have changed the color. The more red it is, that does mean that it is positive in sales. And the lighter it is, it does mean that it is at a negative. Right. This is that negative, and the redder it is, that does mean that the things are like this. Now, if you have, if you hover up to the graph, you can see what is happening and what is not. From here, if you start moving up, you will see this difference of thing. And when you reach over here, you will see some. Here when you were at Q1 of 2020, if you see the number percentage of difference in sales across, you will see minus. And then this you travel the entire way up and you're almost there at Q2. Now you see a positive number coming up, and then they can again travel in the Q3. Your number was over here, and then this. This basically tells Jennifer what it is telling Jennifer. Firstly, quarterly wise, how my sales figures were and what is the trend. The redder it is, the more positive your things are. And also it is giving you the journey between the quarters along the years for this particular thing represented by gradient coloring. This becomes pretty easy for her to know that what is happening and how should I deal with it. Now look at another very strategic visualization that is called box plots. Box plots are very important. You know why I'm telling you? If you guys are anyone who is working, if you guys are working on data science, or if you have any interest towards data science, box plot is one of the important visual that comes into play while you're venturing towards general reporting. Marketing box plots people avoid because firstly, people don't understand box plots. I'm very sorry, but unless people are taught to see this box plot visual, because box plot is a very tactical visual, and I love that visual because a single box plot gives you the minimum value, maximum value and interquartile values. Firstly, interquartile, then it gives you a median, and then it gives you minimum and maximum. One box plot always has 5 different things in a single box. Let's see how box plot works, and box plot is basically used to show distributions and compare sets of data which is highlighted up to the 5 key values of minimum, 25% quartile, median 75% quartile and maximum. Seeing the distribution of value along the axis. And whenever you're working with data science or data, you will see that box plot comes very handy because you have in a single view. You have your entire thing which you can draw inferences from. Let's take a quick example and we will wrap up the session with box plots today because that will be very hard to grasp. And I'll urge you to go. And I don't know if you guys have a license of Tableau, but that always free versions are available for 14 days but then go and practice, at least practice box plots and learn box plots. It is very important in marketing reporting but in data science, yes. Let me pull in, some of the parameters. Let me pull in. See what do I do? No, I am using a free license. Let me pull in segment. Let me pull in region. And let me pull in discount. One more thing is always have your like. If you have your show me thing on what will happen, You will see that as soon as you start putting the things, it will give you suggested graph. See, I put segment, only the table comes up. One more doubt in the visualization. You can see third last one right. In the second last, I didn't understand what there's a graph in second row. Last. Second row, last one. Last section. This one. No above row, last one. Which one? Above bubble chat. This one. No. Last above bubble chat, right? There is a wine cellar. It's like candle graphics. Can you explain why this graph I haven't used anywhere? But what's the usage of that graph? You're talking of this one box and whisker block. That is the graph I'm talking of right now. That is called a box plot, right? Box and whisker plots. That is what I'm discussing. That is what I'm trying to explain you. Wait, hold on. Fasten your seat belts. Now let me put in discount over here. Why box? Now see, as soon as I have two parameters coming into play and then one measurement to support those two parameters. See, box plot gets activated. First thing, you need to have two or more dimensions in order to, qualify for a box plotting thing. You cannot box plot with a like. If you do this, that doesn't make sense. It doesn't make much sense. But always it has to be two or more dimensions qualifying this box plotting. Now let's see why and what happens over there. Now what happens? Like whenever you pull in this scenario, you will see that one bar graph will come up. Now from show me, let's go to box plot. Now what we see is an interquartile range in the box plot. Now if you go over here, what you will see? You will see something called the upper whisker. Then comes upper quartile, which is called as an upper hinge, and then comes your median. Then comes your lower quartile, and then comes your lower whisker. That's the 5 things that we were talking of. When we are talking about this, basically, lower whisker is minimum. Then comes your 25% quartile, then comes your median, then comes your 75%, and the upper whisker is nothing. But it is your upper range or the higher range. What happens is this basically shows you the quartiles and everything and all the things that comes between upper whisker and lower whisker. And it shows you the distribution of data along the line. It shows you that for consumer as a segment, distribution happens like this. But where did region go? As soon as we have selected box plot, what happens is it shows this distribution from the pass of a region. It is showing the distribution of segment. It is showing the distribution of segment. But on what parameter? The parameter being region. On a parameter of region. What is the distribution of segment that is happening? That's why you always need 2 or more dimensions, because it is showing you a distribution, and distribution always comes up with, parameters of parameter which is needed along with, there cannot be a single thing. You may plot it. Doesn't make sense. What is it showing you? It is showing you distribution of segment based on the parameter of region. Correct. Now you see that the region is helping it to have a distribution. Now, if I now pull back region, originally like in a region was not in marks, this is called marks cut. Region originally was not in marks cut, right? But it was from the columns. Correct. Now let me again pull it back to columns. What we see now, it shows us like now. It shows us individual marks in a plot that it should, but that's not how it should be. Now, if I go over here, I don't see the plotting happening. Correct. Now we see that individual marks are plotted. Then it is not plotting a distribution that it should. Clear till now? We see a flattened horizontal line box, right? And we are getting single marks, but we want a distribution. Correct. But as the definition says, box plot is meant to show the distribution of data. Now what we will do? We will now go ahead and disaggregate values. Because now, when we supply region back in there, we want this view made. We want this view to show up my box plot. But what is happening is, while I'm doing the segment and region, I'm putting it back in their respective things. Because this metric is getting aggregated based on these two things. What we will do? We have to disaggregate our measures. How do you do that? You need to go to Analysis and you will see Aggregate Measures from there. You need to just click this and this will disaggregate all your measures. Now what happens in this view itself? I have my plotting happening at upper whisker, upper hinge, medium lower hinge and lower whisker. To have a much more informative view, what do? We program this. What do? We pulling, like we just rotated the graph and what do we see? We swap the axis to have a horizontal view. Now that we see that, based on my region and based on my segment, how is the thing plotted? How are things plotted and how do we see this and how can we take any of the inferences from it? You can go ahead and you can change everything. You can format and stuff you can do over here. But that is not the thing. Inferences. What is my inference? Inference is discount is pretty much same for all the segments that we have. Because see, all the medians are coming in here. And what is the other thing? That center region is showing the highest range. The region central has gone beyond the 75% whisker and its upper limit is distributed over here. And this is how we can infer that central region is showing the higher range. Discount is same for all the segments. And we can see the minimum and maximum values of the interquartile range. And we can determine for each region what is the distribution of discount from the lower level to the higher level. And finally, do not forget to like, share and subscribe to our channel.